Okay, continuing Chapter 3, Mat 1100 review for the test, beginning with number 35 this time. And you're doing another problem with systems. You're checking the point 5,3, and just like 34, you need to, it has to work in both equations. So first equation is x plus y equal to -2. You're trying 5,3. You can already see that that point does not work. You have an 8 on this side that is not equal to -2, so no. 5,3 is not a solution. Answer is B. That's 35. Moving to 36. For 36, you have the first equation being 4x plus y equal to -29. You're testing the point -6, -5. So it's -24 minus 5, because a plus followed by a minus is just a minus. This combined with this is -29. You could always put that in your calculator. You get the same number on both sides, so far it works. Now go grab the bottom equation, which is 2x plus 4y equal to -32. Again, I'm testing -6, -5. Here I got -12. Here I got -20. I'm adding those together, which is -32. So it ends up working for both of them. Okay, so the answer is yes. This is a solution. Choice A. Okay, moving to 37. In problem 37, you are going to solve this system. It doesn't say what method, but they've actually set you up for substitution. When they get one of the variables all by itself with a 1, they've isolated that variable with a 1 in front of it, they're setting you up for substitution. You can now go and substitute this -2x right in there for y, because it's equal to y. You're allowed to plug it in into the other equation for the variable that it's equal to. So here we go. I'm going to copy the x, but right in here for the y, I'm going to plug in what y is equal to. The bottom equation says y can be, that -2x can be used for y since they're equal, and then copy the rest of that top equation. So it's x plus what used to be y is now -2x. Now I only have one variable. That's the whole point of substitution, to get rid of one of the letters so that one of the variables so that you can solve it. Okay, 1x take away 2x is -1x. Divide that -1 right off of there, and you end up with x equal to -3. So that's half the answer. These systems that you're being given have both an x and a y value. Okay, now once you get the x value, you can plug into either equation. I'm going to plug into the bottom. Y is equal to -2 times x, which is +6. And then you take these values, collect them together, write them as a point. -3 for x, 6 for y. Okay, 38. 38 they've also set you up for 38 and 39 as substitution. Once you get to 40 and 41, then they're trying to get you involved in the other method, which is elimination. Okay, so continuing with 38. I'm going to do the work right here. You have x plus y, which is equal to 12. This is the top equation, but in for the y, I'm going to substitute 5x, because the bottom equation says that those two things are equal, so you're allowed to plug in one for the other. This is 1x plus 5x, 6x equal to 12. Divide by 6 on both sides, you get x equal to 3. Once you get one answer, you can plug it into either equation, top or bottom. The bottom one's easier to get its partner. So the bottom equation says that y is equal to 5 times x. So this would be the other partner. The values are 3 and 15 for the y partner. Okay, 39 has a little bit more work than 38 just because it's an entire expression, so I'm going to move over to paper to do that one. Okay, so 39 is x plus 4y. X plus 4y is equal to 157. And then the bottom equation is y is equal to 6x plus 8. Okay, so just like numbers 35 and 36 where I did substitution, I'm going to do this one the same way, only because they have isolated one of the variables, leaving just a coefficient of positive 1 in front of it, and so that's the prime form that you would get it in if they were trying to prompt you into substitution. So I'm going to substitute this in right in here for y because it's equal to y. So here I go, copying the top equation, but leaving a blank spot where I'm going to plug in. Okay, where the y is, I'm allowed to put anything that's equal to y, such as this, 6x plus 8. Plug that right in there. Then you can distribute the 4 to both of these because that's what these parentheses mean. You can drop down this term but distribute the 4. So 4 distributed to 6 means you're multiplying. So that gives you 24 x's. 4 distributed to 8 means you have 32. Drop down the equal sign and the 157. Clean up the left-hand side. You have 1x plus 24x is 25x. Drop down the positive 32 and continue to solve. Attempting to isolate that 25x means we're going to take the positive 32 to the other side by subtracting 32, which is what this arrow means. Okay, so now the 32 is over there, now acting as a negative, so this would be 125. Drop down the 25x and go in for that last step. Divide by 25 on this side as well as this side, and you get x is equal to 5. Okay, now you have half the answer, and you go and choose something to plug in for, which I'm going to plug in right here. So that's the easier way to go. I'm going to plug in for y to get the y partner. So it's 6 times what you got for x plus 8. And I got a 5. This would be 30 plus 8, or 38. And you can take your answer and collect it together. X is 5 while the y partner is 38. Okay, that's problem 39. Okay, once we get to this problem, now we're getting to problem 40. And in problem 40, the way they have the equations set up where we have a column of x's, a column of y's, and a column of constants, this would be good for the elimination method. So what I'm going to do is I'm going to go after trying to get the x's to go away because that would be easier than trying to get the y's to go away since both of the coefficients are different. Here, if you try to go after the x's, you have a 1 in front of the x that's at the top, and you can just multiply that entire equation by -2. That'll turn the top x into -2x while the bottom will be +2x, and then when you add the equations together, they'll cancel. So here's what the top equation looks like after I multiply the entire thing by -2. It'll be -2 times 1, giving you -2x. It'll be -2 times -2, so in the middle you'll have +4y, and then it'll be -2 times 4, which is -8. Okay, then you're going to bring the bottom equation over. Okay, and this is at the point once you get either the x's or the y's to be like this, where the coefficients are opposite signed but the same coefficient. You add the equations together, that makes one of the columns go away. 4, take away 3, it gives you 1y. Negative 8 plus 3 is negative 5. You have half the answer. Now, regardless of what method you're using, once you get one answer, you go and get its partner by plugging into any equation in the system. I'm going to plug into the top one. So here's the rest of the work. It's x minus 2 times y, that's the top equation, equal to 4. I just found out that y is negative 5, so it's x plus 10 is equal to negative 4. Bring this 10 over here, at which point it becomes a negative 10. So it's what I just did by way of this arrow is minus 10 minus 10. So now you have x is equal to these two numbers combined in your calculator, or you can do it by hand, is negative 14. So the answer for 40 is, your x value is negative 14 and your y value is negative 5. Okay, 41. 41 is the same thing as 40. You have a 1 in the top equation in front of the x. In the bottom equation, right underneath it, you have an x but with a negative 6. Therefore, you want the top to be a positive 6. So that number 1 is very easily transformed into whatever you want it to be. So it's going to be 6 times 1, 6 times 9, 6 times 18. I'm going to put this down here so I don't cram into the work I just did. So 6 times 1 is 6x. 6 times 9 is 54. And then 6 times 18 is 108, but it's negative 108. And then the bottom equation, you should copy it without making any changes, because now they're all ready to cancel, the column of x's, that is. Okay, once you get it to the point where you either have the x's or the y's ready to cancel, like we do here, x's are going to cancel, then it's time to crunch the two equations together through addition, eliminating one of the variables. Here you're going to get 64 as you add 54 to 10, and when you add these two, you get negative 128. Okay, then the step right before you get to the y is you're going to be dividing by 64 on both sides, giving you y is equal to negative 2. So I have part of the answer, and now I go after the other answer. I'm going to use the equation at the top, x plus 9y equal negative 18. I already know that y is negative 2. So I just found that right here. So this is x. Positive 9 times negative 2 is negative 18. Oops. Copied the right side incorrectly. So this is what I have at this point. Then I'm going to move this negative 18 to the other side, at which point it will become positive 18. Again, what this arrow means is that I have either added or subtracted. I've done the opposite of whatever you're seeing here. So I've added 18, added 18. This gives me x equal to 0. And then take these numbers and collect them together. Your x coordinate is 0, your y coordinate is negative 2. Okay, that takes us up through 41. Okay, moving on to 42, same problem. So in problem 42, I think I'm going to skip over that one because I've already done plenty of those. You can refer to 40 and 41 for that particular type of method. Okay, 43. Following table contains input-output values for a function. Is the function linear? So what you want to make sure in order to pick whether it's linear or not is that you want to run down the column of y's, making sure it's the same difference between any two numbers. any two successive numbers. So the difference between here and here is, and you can go to, you can pick any two numbers, but it has to be the same all the way down. Now, if you don't want to check every single one of them, I guess checking a few of these would be okay. So you could just go this number minus the next one, negative 26 minus negative 20. You get a difference of negative 6. Let's check this one. Negative 20 minus negative 14. Negative 20 minus negative 14. You get a difference of negative 6. Same thing here. Negative 14 minus negative 8. And the same thing. So you can rest assured pretty much that if you've gotten the same answer 3 times, it's going to happen all the way down. Okay, now you want to make sure, now this is what we call the rise. And actually, when it's consistent all the way down is how you tell whether it's linear. So you want to make sure this has the same change also. So this is negative 6 minus negative 4, which is negative 2. Negative 4 minus negative 2, again, negative 2. So these numbers don't have to match these, but there has to be consistency all the way down the column. So negative 2, take away 0, it's just one number minus the one below it, is also negative 2. So yes, this is linear for number 43. In problem 44, you're also going to be checking whether you have a linear relationship here. And so again, you're going to go down the y's, down the x's. So the difference from here to here, if you go 19, take away 25, there is a difference of 6. If you go 25 minus 31, there's a difference of 6. If you go 31 minus 37, there's a difference of, each one's a difference of negative 6, all the way down. Now let's make sure these are all the same, because they have to be the same also. So 9 take away 11 is negative 2. 11 take away 13, negative 2. 13 take away 15, negative 2. So this appears to be consistent all the way down the y's, all the way down the x's. So yes, this one is linear. Okay, 45. Same question. Let's see if there's consistency here. From here to here, adding 5. From here to, now you can see it's already messed up. The y's already show an inconsistent increase. The increase from here to here was 5. The increase from here to here is not the same. You don't need to even bother continuing. So not linear. Okay, moving on to 46. A system of two linear equations has been solved, meaning they've already graphed it. All you have to know is that the point of intersection is the actual solution to the problem. So that's the answer, right where they hit. You don't even have to graph these. Okay, so where do they hit? At, you just want to name the point. At 4, 2. Okay, here the solution is 2, negative 2, right there. You don't have to actually label it both places. Okay, 48. Find the equilibrium point for the given supply and demand functions. This is supply, this is demand. Equilibrium means when these two equations are set equal. What you want to set equal are the portions on the right-hand side. So the equilibrium point would be when 6,500 minus 100x is set equal to the right side. You're using just the right sides, 160x, and then you're going to solve for x. So when you're solving an equation like this, you need to get all the x's on the same side. So we're going to move this term over to the right, at which point it will become 100x. So I'm adding 100x to both sides. So this is no longer here, it's over here. Now you have 260x while you have 6,500 here. Okay, then to finish this, you need to divide by 260 here as well as here, and you end up getting 6,500 divided by 260, which is 25 exactly. Okay, and then if you want to get the Y partner that goes with this, since this is all about systems, this page, you can go and get the partner that goes with this by plugging in that 25 into either this equation or this one. This would be the easier one because you could go directly to Y by going 160 times the X value. Either one's going to give you the same answer, it's just that one's more work than the other. So 160 times 25, and you get 4,000. So that when they said find the equilibrium point, that meant both parts. Whoops, let me slide this over. Sorry about that. Wasn't showing you what I was doing, but I began the problem by setting the right-hand portion of the top equation equal to the right-hand portion of the bottom equation. That's what we call equilibrium when they're equal. Solved for x by moving this negative 100 to the other side, giving me 260, then dividing by both sides by 260 to get the x coordinate. Then I took this x value, plugged it into the bottom equation to get its y partner. So this is what we call the equilibrium. I'm going to abbreviate here, the equilibrium point. At 25, you have a y partner of 400. Okay, that's 48. Oops, I think I need to fix that. This last problem that I just did, I think I left one of the zeros off. Yes, when I did 160 times 25, that should have been 4,000. Excuse me, please fix that. So 25, 4,000 is the equilibrium point. Okay, moving on to 49. Okay, so 49 says this isn't a revenue equation. This is the equation where X is the number of bottles of mouthwash sold. Y is the total income of X bottles. The cost equation is this, the following, and where X is the number of bottles of mouthwash. The following set of axes shows the graph of the cost and the revenue equations. So the following says, and where's the question? The question is, here it is down here, find the coordinates of the point of intersection, or what's called the break-even point. And they've already explained to you what the break-even point is. It's the point of intersection, which you can see is right there. So let's try to approximate what this point of intersection is. It seems to be slightly past 3,000 as far as X coordinate. So you're about right here. It's a little bit past 3,000. Let's look at these choices. So it can either be this one or this one. I guess they're calling that 3,125. And then the y coordinate is just slightly past 4,000, which they're calling 4,062 and 5. Now, since both of those answers, part B and C, this is out of the running, this is out of the running, have the same numbers in the X and Y position, you are then asked to go and interpret the meaning of this. So for 49, the choice would be 3,000. Okay, now you're looking at the words that they've attached to these numbers. They're both the same as far as just the numbers, but then they go on to interpret them. This 3,125, being that it's along the x-axis, should be using this phrase to describe it. So 3,125 bottles. That would be choice C. And that's for number 49. Okay, 50 through 54 to finish up this review. For number 50, all you're doing is dividing by 3 to isolate the A. Negative 12 divided by 3, negative 4. So that's your answer for 50. This one, you're going to be, I think I'm going to add 10 to both sides. I'm going to get rid of that negative 10 first, leaving me with 10x. The 10s would be gone. And on the right side, I'd have 100. So I just added 10. You can use the arrow, or you can actually show what you added to both sides. Then go into the division step. That division step will always be your last step. This answer is 10. And moving to number 52. I'm going to move that over here so I have a little bit of room to work. It's negative 13 equal to 5x minus 8. You're always trying to isolate the x regardless of what side it is. So first thing I think I'm going to do is move the negative 8 to the other side, at which point it will become positive 8. So this is gone. Only the 5x remains on the right-hand side. This plus this would be negative 5. And then that division step, as I said, is always the last step. So x is equal to negative 1. And there's your solution for 52. 53, I'll do that down here. Copy it here so I can have a little room. Okay, again, you have x's on, this is an equation where you have x's on both sides. All of them need to be on the same side, so I think I'm going to move this over here. If this is positive, it would appear as a negative on the other side. So that's like subtracting 2x, subtracting 2x. In any event, the 2x is gone on the right-hand side. Now it's over on the left-hand side. And when you combine the x's, you get 4x. Drop down the positive 12. 2 more steps to go. Move this to the other side, which would make it a negative 12. So it's like you subtracted 12 here and you subtracted 12 here. It's just that when you use the arrow, you're not actually showing this number on both sides. Just a shorthand way for dealing with it. 32 minus 12, 20. 4x right here. Last step. Always the last step is the division step, divided by 4. Your answer is 5. This was x equal to negative 1. This one's x equal to 5. The last one, number 54. 54, I'm going to just look at it right over here. There are several x's on the left-hand side. You want to combine them all into one. So first I'm going to combine the negative 2 with the 5. Negative 2 plus 5 is 3. Then I'll add the 7 into that. So 3 plus 7, 10x. And then on this side there's a negative 60. Continue to solve by doing that last division step. And then you're at x is equal to negative 6. And that completes the review. Okay, see you in class on Monday. Good luck studying.